Welcome to this video. In this video, we're going to talk about ctrlX Core IDE app, Programming Made Easy. Now this app allows you to program the ctrlX Core using Python, JavaScript, or block view. Let's understand more about this app. There are several benefits of using this app because this app provides two platforms. One is the visual coding, another is textual coding. Now visual coding is for those who are non-programmers or process experts who don't know how to write the code, but they can still use visual blocks to program ctrlX Core. How to do that, we will see in the next slides. Other than that, you can use textual coding, which is based on Python IDE. It's a coding platform for Python, which supports syntax highlighting for languages like C++, HTML, and JSON. So let's understand how you can program ctrlX Core, first using visual coding, which is based on Microsoft Make Code. Now this visual coding platform offers you to switch between JavaScript and Python. And block view, you can switch between three different platforms. So if you're programming in JavaScript and your colleague is programming in Python, you can program independently and you can synchronize your project. So let's see how we can do that. So in the first example, we will write a program just to display a text on the log. So in this case, I will open my ctrlX Core and make sure you are logged into your ctrlX Core and you have IDE app installed with a valid license. So I will open my IDE app and go to my visual coding, and it will open a platform which is like a make code. So let's create a new project. I give a name to my project. Let's say my project 1. And your project is created, and I have several functions on my left: motion, in, out, control, loops, logic, variables, and so on. So I'll go to my advanced and go to my console. I'll take a console log out, and I have to type a code which is hello ctrlX automation. Simple as that. I'll type a string hello ctrlX automation. So this is a simple text which will be displayed on the log. But to finish the code, I want to exit this code as well. To do that, I will go to my control, take my exit function, plug it on the bottom of that. And I would like to add some delay here as well. So in this case, I will find a delay in my loop. I have a pause function, and I would like to add a delay in the beginning. Let's say 1 second delay. And before we exit, I would like to have a delay as well. Let's say 5 seconds. Now in this case, when the function starts, I have a delay of 1 second, and then I have a text message, hello ctrlX automation, delay of 5 seconds, and then I exit. So let's run that. I go to my compile, and the compile function will show you some error in case if you have error. Let's start it. And here you can see that it starts, hello ctrlX automation is here, and after 5 seconds, it will exit. Now this hello ctrlX automation is also displayed on the log of ctrlX Core. Alright, this was a very simple example, but you know that if you have several functions here for control, for loop, for logic, you can make example of your own choice using this function, which makes it very easy. Let's implement another example of logic, but now in case of simply displaying the text, we're going to use ctrlX IO. If you have seen my last video, I have explained how via EtherCAT you can read-write information from your ctrlX IO into ctrlX Core. If you haven't seen this video, check out the pop-up on the top where you can find this video very easily. So let's see what is the second example. In the second example, we want to actuate channel 1 output of ctrlX IO using channel 1 input. So let's see how we can do that using IDE app. I will go back to my ctrlX Core, and here I'll go to in-out. In in-out, I will first define my IOs. In this case, just click on that and go to configure. When you go to configure, here you can see that I have my address prefix already added. Now this prefix address is coming from my data layer because my ctrlX IO is sending the signal to my data layer. To understand that in more detail, I will open another tab. Let's open ctrlX Core here. And you can see my field bus, EtherCAT, master, instance, EtherCAT master, real-time data. And this real-time data I can copy from here, and this is the path which I pasted here. Very easy. Now you can go to ctrlX core again. You can go to your input, and in the input you will find your module, and then you will find channel 1 value. This channel 1 value is coming from my ctrlX IO, the real-time value of my channel 1 input. At the moment you can see that this value is false. That's alright, I will copy that path. Go to here, create a new variable. Let's call it input1. And now comes the address. Now because I already have my prefix there, I can just type input. And I can add it. This is type as digital input, and you can add that here. Similarly, I can add one output. In this case, I will write out1. And now I need an address for the output. I open my output, data, module, channel 1, copy that easily, go back here, put the address without prefix. And here I need to select the type, which is the output. Click add. Now we have one input and one output defined. Let's save it. And now I don't need this output. I can change my code, and I'll take an if-else logic. I bring it out here. Now here I want, if my channel 1 input is true, the output should be true. Simple as that. In this case, what I can do is, I will go to my in-out. I want to read an input, take it out, and I want to write an output. What input I want to read, I can select from here because I already defined this input, input 1, and I want to write output 1. This you can quickly drag and drop into this condition. Now this means if input 1 is true, output 1 should also be true. Drag the output here and select high. This means if input 1 is true, digital write output will also be true or high. If you want an else situation, click on this plus button, and I will copy this one, bring it that here, and make it false. So if input 1 is true, output is true, otherwise output is false. Simple as that. Let's try how does it work. I will compile it, and I will start triggering it. Let's see what's the status of my input. My input is false in ctrlX IO, so let's manually turn it true before I execute. Now my input of channel 1 is true. Let's start. And you will notice that my output is true and program exit. All right. This is how you can use this block view to trigger your outputs. And now if I make my input false, and I run that again, it will make my output false. Simple as that. So this is about example 2, where we can read the values from ctrlX IO and trigger the output of ctrlX IO. All right, let's make some more interesting example. In the third example, we will integrate kinematics. So we're gonna move the motion of kinematics using our block view. How you can do that? This is fairly simple. In this case, let's go back to our ctrlX core. And here you have to make sure you have a motion app already installed. So this app you need to integrate your kinematics. So in this motion app, what you have axis, axis profiles, and kinematics. So if I go to my axis, I have already configured my axis. So I have my X, Y, Z axis already configured with some limits and some values. For example, these are the actual value of the axis. And if I go to my axis properties, you can find some limits are defined here. Similarly, I have it for Y and Z. So 3 axes are already defined in my axis. And these 3 axes are linked to my kinematics, which are already defined here. So these X, Y, Z are linked to main axis X, Y, and Z. So kinematics will help you to move these axes. So in this case, if you want to see an example, let's go to commission. In the commissioning, you can see that I have my X, Y, Z axis with some values. Let's group this axis. And just to show you an example, I will go down. And here you can see the real-time positions. And let's move these axes. In this case, I will go to positioning. Let's put some value. I will put 17, 23, 56. And if I click on start, it will move the axis to my set points, which is 17, 23, 56, and these are the velocity. Once the axis reach there, you can see that the values are here and this will stop. Again, if I move 100, 200 and start, the axis will start moving. Now we want to move these axes using our visual code. But before we do that, I want to show you some more creative way to visualize the axis. I have an app called 3D Viewer, which you can install, and this app will show you some models. So we have a demo model already inside. Perhaps you can also import your models. So this demo model is linked to the axis. So in this case, if I go to connect and let's bring it out, this would be helpful to realize this model. I'll take this out. Let's group this, go down, and here you can see that I have 100, 256, and this model is also at the same position. If you want to see that, you can show commands 100, 256. Let me just resize that. Now let's move this axis to some new position. In this case, I will go to positioning. I will put 400, 400 and 0. And I will press start. And you will see that this is moving, and here this is moving, trying to reach the position. One more time, let me put -400, -400 and 100, and I press start. And based on the velocity, acceleration, your motion is happening. So in the next example, we're gonna keep this window open, and we're gonna use this 3D viewer to visualize our motion. I will close this window here. Now we have to move the motion from our IDE app. This is also fairly simple without writing a piece of code. So in this case, what I'm going to do is I will delete this logic. I will go to my motion, and I have to first configure the motion. I have to interlink the IDE app with my motion app. So I will go to configure, and in this case, you will see there is an option of axis, kinematics, and points. So first we need to link the axis X, Y, and Z. In this case, the shortcut is click on this icon here. And here you can see your axes which are already defined will be shown here. Click import, and now you have all the axes imported here. Similar way, we can also import our kinematics. In this case, click on this one, and here you have kinematics defined. Click import, and now you have kinematics here as well. The points are the predefined positions, which will make it easy to program our code. In this case, I will go to plus, and let's say I want to define a position. I will write pose 1. Reference, I will take kinematics. In this case, I can define XYZ position. Let's say my X position, I want to write -400. Add Y position, -400. Add. In Z position, let's say 0. So this is my XYZ defined in my position 1. Let's take another position. Now we have two positions with X, Y, Z values defined. Click on Save. This will initialize the program with your axis, kinematics, and positions. Now you go to your motion function again, and here you will find a function move kinematics to position. Bring this to your block. So let me just make it bigger. Now, first thing what I want to do is I want to move it to position 1. So I go here, and here I have my kinematics already defined and linked, absolute position. And here I want to have a position. In this case, I go to motion again, go down, and I have my position 1 here. Let's bring the another position as well. So I have my two positions. First, I want to position 1. This is move here, and you can delete the array by bringing that here. And now I want to have a delay. Let's take a delay. In this case, I will go to my loop, take a delay, let's say 2 seconds. And I will copy paste this command, bring that here, and bring that to position 2. And here you can define the speed. Let's say I define 3000, and here I define 1000. All right. So here you can also define an acceleration. I will keep it to 1, and here 1 as well. Let's give it a shot. I will compile, and I will start, and in this case, let's bring it like this. So you will notice this has started, -400, -400, 0, 2-second delay, and now this is going to position 2. And this is going to position 2 with a speed of 1000 millimeter per minute. Now this has reached to 300, 250. If I want to change the speed, I can do that quickly from here. Let's move it at 6000, and here at 6000 as well. So you can see that just by changing the speed using the blocks, you can quickly change the speed in your real application. And now it's going to position 1. You can see the position being visualized here. Take a 2-second break, and then it goes to second position. Super easy to do that. And now the interesting part is, if you want to change this code using Python, all you have to do is just click here. And then you will see the code block automatically change to the Python commands. And here you can see that motion.kinematics.move, absolute motion, this is the position 1, and that's the velocity. And I can change the velocity from here, 4000, and here I can also change to 5000. And I can run this again. Very easy. Another interesting thing is, if you want to do it in JavaScript, just select JavaScript from here. And now this is your JavaScript environment. In this case, if you want to make some changes, you can add a motion, another motion here, just copy paste. And here you can define position 3. And now, because you made some changes here, it will show you a problem, because this is a real-time checking your program. It says the position 3 is not defined. So what you can do is, you can go to motion. Let's go to the block. Go to the motion, go to configure, and take another position. Let's write pose 3. And now I can add third position just by copy pasting the code. And now you can compile and you can run. Now you can see that how easy it was to add another position in your code, but just by copy pasting. This is the advantage of using IDE app. You can code using Visual Code, you can switch to Python immediately, you can switch to JavaScript, you can change the code in different language, it will be reflected in your other language as well. So this is about how you can use IDE app using Visual Code. Alright, in the next example, let's see what do we have more in this video. The next example, we will talk about textual coding. Now textual coding is basically for application developer. In this case, this is used to execute Python scripts directly without additional tools. So it also makes it easy to access ctrlX motion and ctrlX data layer. So how to use this textual coding? Let's see some examples. In this case, let's begin with first example. Write a script to display a set of number using for loop. Alright, to go to the textual coding, let's go to our ctrlX core. Let's go out of this IDE at the moment. And now I'll go to my home and go to my Rexroth. And now from here you can select your IDE and you can go to your textual coding. And now I'm in my IDE environment for textual coding. And here you can see on my script folder, you can make multiple scripts. So I have some predefined scripts here, which I wrote while doing some practice of my scripts. So I have several examples here. And if you know Python, the .py is the extension of a Python script. So our first example was how you can write a function for a for loop. So this is the function which I've already defined here. I'm just going to show you how you can execute that in your ctrlX core. So that's my function. It says import functools, import system libraries, and then we have a command to flush all prints, and then we have a for loop which says for x in range 2, print x, and then exit. Now in this case, let's run the script. Now there are two ways to run the script. Now the one way is you can run the script on ctrlX core within the Python interpreter provided by Ubuntu Core. In this case, you just have to click the play button here, and this will run in the Python interpreter. So you can see that you have the values 0 and 1. So if I change that to 7 and I run that again, I have my output displayed here. Fairly easy, no rocket science. Now the way to execute the script using Python interpreter does not allow you to access ctrlS motion or ctrlX data layer. To do that, you have to run the Python script in the Python script engine. Alright, so let's take one example. Let's take a second example. In this case, we have to run the Python file on script engine. And in this case, we are again going to interface using ctrlX IO. So this is defined in example 2. So I will open my example 2 here. And you can see that we have a function datalayer.read. This function is only available if you run the script on the script engine. So in this case, if you see the function, I have a variable channel1. It's reading the value of my data layer. And if you remember that, this is coming from my data layer for my ctrlX IO. So I read the channel1 value and move that into channel1. And then I write the data layer with the value which was in channel1, which means it's basically doing the same what we were doing in our visual block. So what happens here? If my input is true, the output is true. Let's see that visually. And to run the script, I have to go to this script engine here. And here you can see that we have an option to run current file and launch Python in script engine. I have to select this one. And in this case, now if I notice my input is false, so my output will be false. Let's actuate my input. Now my input is true, and let's start this Python file. So I will launch this, and this will ask you for an instance, which instance I want to use to run this Python file. So I have my several instances already inside my ctrlX core, so I will select instance 1. In this case, it will select this instance and run this code. And now you can see that my output is true because of my code. So let's just check if my input is false. Now my input is false, and I will run this again. I will select my instance, and you will see that my output goes false. Simple as that. So in this example, we have seen how you can use IDE app and you can read-write the value from ctrlX IO. Let's see what is the next example. In the next example, we're going to do the same which we did in visual block. So we're going to interface our kinematics, and we will see how we can interface value with ctrlX motion. So here I go to my example 5. In my example 5, I have defined how we can read-write the value for kinematics. So here you can see that I have a function import sys, and then I have attached the object XYZ and kinematics, so 3 axis and kinematics like in Visual Code. And then I just define the position. It says motion kinematic move absolute, and this is the kinematics which I have defined. And here comes the position X, Y, Z. Coordinate is product coordinate system with the velocity, acceleration, deceleration, and jerk acceleration and deceleration. So I'm moving to XYZ axis here. And then I move to XYZ axis here. In this case, the Z axis is 0. And then I wait until Z goes to 0. And after that, I bring Z to 100. And then I move to another position, which is X is 250, Y 250, 100, and so on. So you can see that using a text IDE, using the textual coding, you can also control your axis. So let's run the script and see what happens. In this case, I will bring back my 3D viewer. So this is paused on the breakpoint. So let's continue. And now you can see that your axis is moving. It's super easy. So you have seen that if I change the position here, you can change your XYZ position from here directly. All right, this was the example 3 which I wanted to show you. Let's see what do we have in the next example. In example 4, we would like to interface MQTT. Now if you are a little bit aware of IoT, so you can also include MQTT in your Python code using the IDE app. This makes it relatively easy to interface with MQTT broker. So in this example, we're going to publish the status of kinematics via MQTT. So I'm going to show you one example. So I will close this example and we'll go to my folder, and I have an example 6. In example 6, you will notice that I'm using an MQTT library. This is the library which is defined here. And this is the library you will find in your library folder. If you go to MQTT, you have this libraries defined here. So I'm just using this library from this import function, and I have defined my broker address. Now my Python code is trying to connect to MQTT broker, which is defined at this address. To connect to this address, I have to tell you this broker is running on my computer. So this broker is actually running on my Node-RED. So if I show you my Node-RED, I have my broker which is already defined here. Let's load the flow. And here you can see that I have my broker running in my Node-RED in my local computer. And this is the IP address of my local computer. So my broker is running, and I have defined my client name as ctrlX core. So in this case, ctrlX core act as a client. And then I connect to the broker using the port address 1884, which is defined in my broker over here. And then I will just publish to a topic. This is my topic, and I publish hello ctrlX world, and I close it. This is just to show you how you can publish a message on a topic ctrlX on. So let's try that. So what I will do is I will bring this out. And now let's run this Python code. So I will again go to my debug, and I will just run this Python code. And we will see here, there should be an output. So I have to give an instance. Let's type an instance name MQTT. And this is my new instance. So once the instance is running, you can see that I have my message hello ctrlX world. So first this was connected. So if you see my debug window, this is the client. And if I see my payload in my client, ctrlX core was connected. And then it was publishing to a topic ctrlX on. And here you can see the output from my ctrlX on. And then it got disconnected. So you have seen that how ctrlX core has sent a message to my MQTT broker, which is running on my local computer. Now let's take this example with our kinematics. In this case, let's see, we want to publish the status of kinematics using MQTT. So I will run another example, which I already created for you. So I just integrated example 6 with example 5, and this is covered in example 7. So in example 7, you will notice I have a broker address, my port address, my topic, and here we actually don't need username and password. This was just for texting, my client ID, and this is the attaching the motion, kinematics. And there is a connect MQTT function, which is a feedback. If it's connected, I will have a feedback connected to MQTT broker. If not, I have enough different message. And basically everything which we have seen in the last example with the motion, but at the end of every motion, I publish a topic, picked object, or going to position 2. And similarly, I will publish a topic, placed object, going to home position, program finished. So what will happen in this example? Based on what is happening here, I will get a message published to a topic, ctrlX on, and we can see this message here. So let's give it a shot. All right, I have to comment this username password as well, because this I commented here. So now let's try to run the script now. In this case, you have to first make sure you have selected Launch Python and Script Engine, and then you click on Start Debugging. Now, if everything is fine, you just have to type the instance name. I will type MQTT. And now the script should be running and we should be receiving the message. So you can see that I have my message program starts, going to position 1, picked object, and now it's going to position 2, and then it will place the object and then it will come to home position. So you have seen how we have integrated MQTT to get the status of our kinematics. So here it goes down and it has place object. Now it says going to home position. So this opens a wide possibility to connect your system to the IoT world. You can also define the broker located in your cloud, and then your ctrlX core is sending the value to the cloud via MQTT. All integrated in one app, IDE. So in this example, I wanted to show you how you can integrate your kinematics with MQTT using one single app IDE. All right. In the next part, you can also integrate several tools like Node-RED and PLC Engineering to trigger this Python scripts. This is also fairly easy. To show you very quickly, what I can do is I can go to my ctrlX core, I can go to my Node-RED, and I will show you my dashboard. So in my dashboard, you will see there are several scripts already predefined here. Example 1, example 2, 3, 4, 5, 6, 7. And here I can also see the status of my input status 1, channel 1, and channel 2. So at the moment, my channel 1 to 3 is false and output is false. But if I browse my instance, I have two instances running, which is MQTT and PLC instance. So if I check the status of PLC instance, this is initialized. So I can use this PLC instance, or if I want to see the status of MQTT, this is terminated. All right, let's create a new instance. In this case, I will do instance 1 and I press enter and I browse the instance. Now I have instance 1. So I will copy that here, paste that here, and this is initialized. Now I have several buttons here, which is triggering the Python file in my ctrlX core. So for example, this is my example 1 and example 2. And similarly, we have different examples. So let's see the last example, which was my example 7. I want to run this example 7 using my Node-RED. It says example 7 kinematics with MQTT. I can do that here directly from here. And to show you the motion, I can show you that here. And let's run this one. So you can see that this is busy and this is running here, following all the signals from our MQTT ctrlX on topic. So the idea of showing this example is you can also trigger your Python script from your dashboard. In this case, you just have to provide your script path and you have to provide the name of the instance you want to use. To learn more about how you can program using Node-RED dashboard, you can copy my code, you can have a look at my code, and this code is given in the video description. Just go there, check out the link of my wiki where you will find all the code how this is done. The idea of this video is to show you the possibilities, the various possibilities of executing your Python script via ctrlX core script engine or via Node-RED. And also the third option is you can also do that via PLC app. This is also fairly easy. To do that, what you can do is you can go to your PLC core app. So once the script is finished, you can see that it's busy and now this is finished. So let's see that quickly again. I will go to my ctrlX core. And here I can go to my PLC app. So you have to make sure you have installed the PLC app with a license. And then you can go to your PLC Engineering from here. And this will open your PLC Engineering. So this is your PLC Engineering app. And first thing you have to make sure is you have added the library of Python in your PLC Engineering tool. In this case, you can go to Library Manager, and here you can click on Add Library. And once you click on Add Library, you can go to Application, ctrlX Automation, Base, CXA Python. So make sure this is added. In my case, this is already added. So I have an option that says the library is already inserted. So once your library is inserted, you can use the code which I'm using it here. This code you will always find in my description of the video. So in this code, all you have to provide is the name of the instance. So here it's PLC instance. Let's change it to PLC instance 1, for example. And then you have to provide the path of your Python file. So you have to make sure you use the same path, active configuration, script, example2. And if you see that here, this was here. This is the example2 here. So active configuration, script, example2 Python. In this example, what do we have? With one input, oops, my bad. The ctrlX IO output is triggered by the ctrlX IO input. Very simple example. So this example I've mentioned here, example2.py. And below, if you see the code, you have the possibility to enable the script instance and execute the file. So let's download the logic and see the result to see how we can execute a Python script using PLC Engineering. So I'm going to download that, and this is going to be downloaded into my ctrlX core. And here we have given PLC instance 1, which you can also see that here. So is it in the stop mode? Let's go to run mode. So instance name is PLC instance 1. So let's have a look at the moment. What's the instance running in our ctrlX core? So at the moment, no instance is running. So let me just minimize that. So we will enable the instance from this Boolean tag here, be enable instance. So I'm going to make it true. And once it's true, I'll just manually transfer this value. So now this is true. My PLC instance 1 should be active. Let's have a look. There you can see now PLC instance 1 is there. And if you want to see the status of this instance, I will just type here PLC instance 1, and this is initialized. Okay. And now what we need to check is what happens when we trigger this script. So the script which we are triggering is example2. If you notice here, I have mentioned my example2. Now what is this example2? In this example2, which I have shown you, we are just activating output based on the status of input. So if you see my dashboard at the moment, my input is true. So if the script is running, this should activate my output. So let's execute the script now. To execute the script, you have to make this Boolean tag to true. All right, so I'm just going to do that. Write the value, and now you can see that my output is true because my script is executing. Okay. And this you can also see in my ctrlX core and ctrlX IO. On the trainer, you can see that my output is true. So let's make the input false to see if the script works again. Now my input is false. Now if I execute the script again, so I will make it false and I will make it true again. In this case, my output is false. And you can see the status of my script here. This is executing and then it's terminated. So one more time, if I make it false, turn on my input, and then I make it true, this will actuate my output. Fairly easy. By just changing the path of the script here, you can execute any script you like from your PLC Engineering software. So this is the topic of today. I know this was a lot of content, but I hope you could understand the possibility of using IDE app to execute Python scripts using Node-RED or using PLC Engineering tool as well. And for the reference information, there are some links which I have mentioned here. To know more about the ctrlX core automation, you can visit the examples, which is the link here. And I have also mentioned this link in the description of the video. To know more about ctrlX IDE app and ctrlX automation, you can also check another links in the video. And if you want to have a copy of all the programs which I've used, all the examples which I've used, you can go to wiki.codeandcompile.com/IIoT. And this is also given in the description of the video. All right, so you have all the documentation, all the examples which I've used in the video. You can access that right away and use in your project. So thank you for watching this video. I hope you like this video. And if you do, please subscribe, like, and share this video. And see you soon with another amazing topic on ctrlX core. Thank you for watching and have a nice day. See you in the next video. Bye-bye.